Okay, graphs of logarithmic functions, that is what I'm going to discuss in this video. But I'm going to discuss first exponential functions before discussing logarithmic functions. As we've seen before, we have a raised to x is equal to y, and the inverse of that is that a raised to y is equal to x. That is what we did before. And then instead of writing this way, because we always have y is equal to something, then we have y logarithm of a with the base a is equal to, sorry for that, logarithm of x with the base a. And we know that this is a, so we have y is equal to logarithm of x with the base a. So they are inverses. And if I'm going to show you the graph of the first graph now, this is the graph of y is equal to a raised to x. Right now a is 0.4. If I'm going to change it, then you can see that if a is equal to 0, there is no graph. And if a is equal to a is equal to 1, it is just a straight line. Then one thing that we need to see here is there is an intercept, y-intercept here. Right now it is a, that is 1. And there is an asymptote, this one, y is equal to 0, or the x-axis, that is y is equal to 0. Why? Because if I'm going to show you more, you can see that it doesn't touch the x-axis. So we have the intercept where x is equal to 0, and we have the asymptote where y is equal to 0. And as you can see here also, we have all the values of x. We can have the values of x as our domain, but our range is only when y is greater than 0. Now we're going to look at the graph of logarithm, and let's see what we can find there. Right now our base is 0.8, and if I'm going to change that, when a is equal to 0, or the base is 0, there is no graph, as you can see there. And this is what we can have. Okay, so what you can see here now is that there is a intercept, but it is not y-intercept now, it is x-intercept. That's why it is the inverse. A while ago, our intercept is y for the exponential function, but for the logarithmic function, our intercept now is x-intercept when y is equal to 0. And as you can see also, it never touches the vertical axis or x is equal to 0. So our asymptote is when x is equal to 0. That's for the vertical axis. And then you can also see that my domain is when x is equal to 0, or greater than 0, sorry. When x is greater than 0, but our range is all real number. So if I'm going to put them together, you can see that they are what's this? They are inverses of each other, and if I will put in the middle there y is equal to x, you can see that they are the mirror of each other. Okay, to summarize, we have function, the exponential function, the domain is all x in real number, and the range is when y is greater than 0. Exact the opposite or the inverse, when the logarithm of x, we have the domain, we only have x greater than 0, but our range is all real numbers. Asymptotes have for exponential function y is equal to 0, or the horizontal axis, and the inverse is, or the logarithm of x is the vertical axis, or x is equal to 0. Have in mind those properties of the logarithmic functions, and then we will try some examples. Maybe I prepared two here. Let's see. Consider the function f of x is equal to logarithm of x minus 1 with a base 2 plus 1. Find the domain and range of f. Okay. I pasted here the properties of logarithmic functions, and we will use that. Let's say domain. We'll use domain. So domain is when x is greater than 0, but you know that x minus 1, we have x minus 1 there, it should be greater than 0. So it should be x greater than 1. So it says here the domain should be x when x is greater than 1. All x when x is greater than 1. And the range is so that it is y for all y, such that y is an element of real number. Okay, and then we have the b. Find any asymptotes and axis intercepts. That means if before we have like this, we need to find that intercept, and we need to find this one. Before it is the y-axis, or x is equal to 0, but now it is x is equal to 1. This is our asymptotes. Why? It says here that our domain is greater than 1. Greater than 1. X is greater than 1. That means our asymptote is, not asymptotes, asymptote is when x is equal to 1. It will go near when x is equal to 1, but it doesn't touch x is equal to 1. And the intercept, this one, when y is equal to 0, so we have logarithm of x minus 1 with a base 2 plus 1 is equal to 0 when y is equal to 0. We subtract both sides of the equation by 1, then we have logarithm of x minus 1 is equal to 1. And then we have 2, then we have x minus 1 is equal to 2 plus 1 plus 1. A negative 1, sorry, negative 1 there. 2 raised to negative 1. Sorry, I missed that. This should be minus 1 minus 1. This should be, I will put that, this should be minus 1 there. So we have, this is 1/2, and then plus 1 there, plus 1, then we have x is equal to 3/2. That's it. So this is now our intercept, x-intercept. Before I'm going to do C, then we will find D first, and then we can see also if we can graph the the inverse. Okay, so our inverse should be we write here y is equal to logarithm of 2x minus 1 plus 1, and then we have this is our x now is equal to logarithm of 2y minus 1 plus 1. If we subtract both sides of the equation, then we have x minus 1 is equal to logarithm of logarithm of y minus 1, sorry, with a base 2. So if we're going to have bases 2 there now, so we have this is now y minus 1, and this is now 2 raised to x minus 1. Maybe it's better if I do that. Now if we add both sides of the equation by 1, and we have y is equal to 2 raised to x plus minus 1, not plus, minus 1 plus 1. That's our inverse function. So inverse function of x is equal to 2 raised to x minus 1 plus 1. Let's see if we can find also that. Okay, I'm going to sketch now. Where is my here? Here is now I already graph it. As you can see, here now, this is the graph of the logarithm of x minus 1 with a base 2. And the intercept there, you can see now here, it's a. Here is the intercept. 1.5. When x is equal to 1.5, I think that is what we get. Okay, yes, when x is 1.5 here. Here. And then, the other one, the inverse, is this one. And the intercept is when y is equal to 1.5. As you can see here, the asymptote of f of x is when x is equal to 1. It is very near 1, but it will not touch x is equal to 1. So that is our asymptote. Okay, let's see another. It's 13 minutes already, but we're going to do this. Okay, find the equation defining the inverse. So we have here, we have y is equal to e raised to x minus 3. Okay, so we have x is equal to take the inverse, e raised to y minus 3. And if because the base is e, then we need to use logarithm, natural logarithm. My tongue cannot pronounce natural logarithm. Okay, and then we have ln of e raised to y minus 3. Then we have ln of x is equal to y minus 3 ln of e, and this is 1. So if we subtract both sides of the equation by 3, add, not subtract, then we have ln of x plus 3 is equal to y. That's our inverse. Or if you want to use the f notation, then the inverse of x is equal to ln of x plus 3. Sketch a graph. We're going to sketch a graph, state the domain and range. And we're going to find any asymptotes and intercepts of that also. Okay, let's say if we sketch a graph. I sketched already the graph here, as you can see here. For the green line, it is the e raised to x minus 3. So you can see that our domain x is for all x, but our range is only when y is greater than 0. For the inverse, we have our domain is when x is greater than 0, as you can see here, and our range is all y. So if I'm going to write that now, write that down, domain, so we have f of x, we have f minus 1, no, the inverse, sorry. So we have the domain. It says there that for all x such that x is an element of real number, but here we have x such that x is greater than 0. That is what we saw. Range, we have y such that y is greater than 0, and here y such that y, for all y such that an element y is an element of real number. Now let's take a look at the asymptote. Okay, as you can see here, the asymptote is for the green one, green line, it's very near x-axis. That means it should be y is equal to 0. And for the blue one, very near the y-axis, that means x is equal to 0. So if I'm going back here now, the asymptote is for the green one, we have y is equal to 0, and here is x is equal to 0. Now we're looking for the intercepts. That means for the green one, what will be the y when x is equal to 0? So y, I'm going to get another pen. Y is equal to e raised to x minus 3 when x is equal to 0. So we have y is equal to e raised to negative 3. So for our intercepts, I will call it I. For this one, we have 0 and e raised to negative 3. So if I'm going back here, you can see that point is e raised to negative 3. And the one that we're going to look now is when y is equal to 0. Let's see if we can find that also. The other one, when y is equal to 0. So we have y is equal to ln of x plus 3 when y is equal to 0. So if we subtract both sides of the equation by 3, then we have y minus 3 is equal to ln of x. And then we have either, and y is equal to 0. Remember that y is equal to 0. We need to find x. And then we know that this is now e raised to 0 minus 3 is equal to x. Then we have x is equal to, here now, we have e raised to negative 3 and 0. Now we're finished with that. It's almost 20 minutes. I think this is the longest. On my next video, then I will be discussing applications of logarithm in growth and decay. So I hope you learned something in this video, and hope to see you again in my next video. Have a nice day. Thank you for watching.